Hey guys, it's Roya, and today I'll be talking about kinetic friction. So friction is something that occurs when two objects slide against each other, and the interactions of their atoms create a force that works against their movement. So let's look at two surfaces. You may think that these two surfaces are flat and smooth, but in reality, they have little atoms sticking out all over the place. And so when these two materials rub together, the atoms have chemical interactions that prevent the movement of the two materials against each other. So let's look at a slide. So here's a slide, and Johnny's sitting on the slide, and it's a metal slide, so he goes down pretty fast, and there's really very little force stopping him. But what if we were to look at a slide made out of something like sandpaper? Of course, that would never happen. But if Johnny sat on the sandpaper, there would be such a large force preventing him from moving down that he'd just stay where he was. So, the difference between these two materials can be shown by their coefficients of kinetic friction. And the coefficient of kinetic friction can be shown by the Greek letter mu with a sub k for kinetic. So, a material like sandpaper would have a very high coefficient of kinetic friction, whereas a material like metal would have a much lower one. Force due to friction is shown by F sub F, and this equals mu k times normal force. And this is because if you look at a box sitting on the ground, if the box is empty and you try to push it, it'll move pretty easily because there's a very small force acting against it. However, if this box were full to the brim of watermelons, for instance, then you would have a very tough time pushing it because there would be a very large force moving back at you. Why is this? It's because this box has a higher normal force. Remember that if we were to draw a force diagram, and if this were the box, then it would have a force down of gravity, mg, and then normal force would have to cancel it out because the box is not moving up or down. So if we were to look at the bigger box, we'd see a much bigger mg and therefore a much bigger normal force. And this is what goes into the friction equation, which is why F sub F of the full box or the heavy box is much greater than that of the empty box.